Okay, everybody, I'm back and I'm here to discuss about the magnetic field. Last time, and I'm going to have to change this so you guys can see what I'm doing a little bit better. And you don't need to see me. I'm not that important. What's important is this. I already made this video once, and you couldn't really see what I was doing with the magnet. So now I have to make it again. So anyway. What we have here is two magnets, and what I'm doing with these two magnets is showing how one magnet actually works. At the center of each magnet is the equatorial plane, right here. You can see the equatorial plane is right here in the magnet. In fact, if I take these magnets out, supporting like that, the equatorial plane is right in between those magnets. Just like that, okay? Now, the energy flows from this equatorial plane up to either anode. So we'll call this equatorial plane also a common cathode. And it's also the magnetodielectric inertia plane, where the inertia of the energy is all flowing in one direction and then coming out the other side. So, but I'll explain that a little bit more later. Right now, the energy coming out of the equatorial plane will go to both anodes of the magnet, meaning north or south anode. So it's going to shoot that way or that way, and you can see that it's quite happy to do so with just a minimal amount of force. I'm not even really forcing it, I'm just putting it there, and there it goes. And there it goes again. So what's happening is that does that from the whole magnet. It comes out like that, and the whole thing from every side, no matter where you are, it just does that. Boom. From the equatorial plane to both poles. So it comes out to both poles like that. Now you have to have a return. So let's call this the North Pole. And so the energy is coming to the North Pole, and it's going to this little hole here in the center. Well, this little hole here in the center represents the South Pole return of the magnet. So it's actually creating a South Pole return, and it's also creating an energy zone, just like electricity. When you touch the hot to the neutral, it creates a spark. What happens here at the North Pole is when the northbound energy touches the southbound energy, it creates the magnetic flux, which out around the magnet. So it's a pressurization zone. It creates a pressure, which creates a magnetic flux around the magnet. So what this does now is this coming in, it's coming around here and then back in the South Pole here. It comes in and then goes through the magnet, but it doesn't go back around and a continuous circle like this. What it does is it goes through the magnet and then back out this side and then back in this way. So it comes back. The South Pole return energy comes in through the North Pole of the magnet and then out through the outside of the South Pole, and then returns to the North Pole return of the South Pole. And does everything out this way. It goes in and then out. But these are happening at the same time, so it's creating a large pressure, which pressurizes the magnetic flux or the magnetic field that surrounds the magnet into existence. So now that I've said that, what happens is, and it's going to be difficult for me to show you in the air, and I don't know if you can see this paper or not too good. It looks like you can. What happens is you got two figure eights, and coming out this side of the magnet, it comes up to the North Pole, and then goes to the left side, to the right side of the South Pole. So it crosses over, and that's why when you try to put a magnet on top of each other and you try to shift it side to side, it wants to go back. It wants to go back in the position because of this situation right here. You can't push the magnet over and let it sit here. It's going to want to come back because of this. And so what's happening is this energy is coming in, and then it's going down, and then it's coming out around here, and then coming in. So it's making a figure eight like this. And the same thing is happening here. This energy is coming here. It's coming around this side, and so it's going from side to side of the magnet. And it's kind of tricky. And it took me a long time to figure this out. I've had a lot of different views on how the magnet works, including the same kind of views as Ken. I can't remember his last name, but he's got he's done a major thing on magnetic fields and stuff like that. And very good, by the way, but his exact opinions on how the magnet works is not exactly correct either. So I had to, and it took me several years to figure this out, to figure this portion of it out. I've had a lot of failures in trying to invent free energy because of my understanding of how the magnet works. That's all going to change now, and the reason how I know that is because the free energy, the shock free energy device, it is working on a principle. It's working on a principle reverse of what I'm trying to do. So all I have to do is reverse that principle, and I will be able to extract the electrostatic field from the aether, or from the atmosphere. Anyway, that's part of what I wanted to talk to you about. Now, the next portion of what I want to talk to you about is how my device is working. What was happening here is the shock-free portion of the device is taking the electrostatic field out of the line. Now, science won't tell you that there's an electrostatic field present on the line, but my device is connected in series, and it's just floating there. It doesn't have a ground connection. It's not connected to neutral or ground in any way. So it's not creating an EMF, an electromotive force. It's not creating a current draw. So it can't be the voltage of the electromagnetic field or the current of the electromagnetic field that's creating the shock just from the power line alone. It has to be something different. And that something different is electrostatic charge. The electrostatic charge is being induced into the line, into the hot line, through the generators themselves. The vibration of the generators is creating a friction, and not only that, but the alternating current itself is also creating a friction in the line, which is creating the electrostatic field to the potential of the electromagnetic field. And that's why the shock is so severe, because the potential of the electrostatic field is the same as the electromagnetic field at this point, and that could be very large. So my device what it's doing is the magnet is creating quasi ground to electrostatic charge, and it's taking it out of effect, and therefore there's no shock on the line, and we're all good. And with that, I will let that go, and I'll get with you next time, hopefully with another device that does something even better. So thank you for your consideration, and I'll get back with you. Goodbye.